Okay, boys and girls, today we're going to be using RATEY to graph rational functions. Hopefully you have this copy. We're going to reference that a lot. The RATEY is just an acronym for roots, asymptotes, tendency and togetherness, and behavior, and the y-intercept. So we're going to reference this a lot, and this is probably the only time that you see this on here, and I'm just going to talk about it from here on out. So be sure we have that. Okay? All right. So let's take a look at number 1 on our notes. See if we can find it. There we go. All right. So the R stands for roots, so we're going to set the top equal to 0. So 4x minus 12 equals 0. We add 12, we divide by 4, and then my root is 3 comma 0. The A stands for asymptote. Set the bottom equal to 0 and solve. X minus 1 equals 0, so then x equals 1. We don't have anything squared. Tangency is like x squared or x minus 1 squared. Tangency is in the numerator, and then same thing, togetherness would be in the denominator. So we don't have any of that. In behavior, now if you look at the E, and you see that if we have the same degree, the degree being the exponent, so 4 to the x to the 1, x to the 1, we're just going to name the coefficients. So 4 over 1 is just 4, so y equals 4. Last thing, our y-intercept, plug 0 in for x. So I get negative 12 or negative 1, which is positive 12. So my root is 3. My asymptote was 1. My end behavior is y equals 4, so I'm just going to graph kind of the ends of my graph there. Some ugly arrow, sorry about that. And then lastly, my y-intercept is 12. And then from there, I know it's overwhelming, but we just need to focus on either side of the asymptote. So look on the right side first. I have a dot, and I have an arrow, so let's connect them. Then I have another dot and another arrow, so we connect those, and then I'm done. So I know it's a lot of information on that little sheet with RATEY and all that, but it's not too complicated. Our domain is everything but 1. And our range is going to be everything but 4. I know it looks like it gets to 4, but it doesn't quite get there. So negative infinity to 4, union 4 to infinity. Okay, so that's that one. Let's look at number 2, and I just want to work through the RATEY and or just give you kind of a couple suggestions. Before you get started, factor out an x here, so then you have 3x plus 1. So when you set each part equal to 0, you get x equals 0 and 3x plus 1 equals 0. On the bottom, factor that to a difference of squares, so you have x plus 3 and x minus 3. So you have x equals 3 and x equals negative 3 for our asymptotes. We don't have any tangency or togetherness whatsoever. Our end behavior, it's the same as number 1. I have the same x's, so it's going to be y equals 3. And then lastly, if I plug y in, or plug 0 in for my y-intercept, I'm going to get 0. So I didn't do this here. My rate was 0, 0, and then if I solve this, negative 1/3, 0. Okay? All right, so let's look at the graph. I got 0, 0, negative 1/3, 0. I got my two vertical asymptotes at negative 3 and positive 3. My end behavior is y equals 3. That's it. I already got my y-intercept is 0, 0. So now we got to talk about it. Well, if this goes down or this goes up, it could look completely different. So how do we know? Well, if this goes down, I'm going to create another root at like negative 5, negative 4, somewhere around there. Well, I only have 2 roots. So that means that my graph, instead of going down, has to go up. Same thing on this right side. It's got to go up because if it went down, it's going to hit another root. And the last thing, we didn't have togetherness. Now, I haven't talked about togetherness, but together would be like this around the asymptote or like that around the asymptote. Well, we don't have togetherness. So if this side goes up, then this side has got to go down. And then same thing over here, because if this one's up, that one's down, and then we just do our best to connect those like that. All right? Our domain is kind of long because we got 2 asymptotes. So it's negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. Big time. All right? Okay, number 3. Number 3's got a squared, so it's worth doing. We'll probably finish with number 4, so you got 2 left here. On the top, we're supposed to set that equal to 0. Well, negative 2 can't ever equal 0, so I don't have any roots. My asymptote, I set that equal to 0, and I'm going to get negative 1. My tangency, I don't have a squared in the top, but I do have a togetherness. I have a squared in the bottom. So that's going to be at that. Let's go together at x equals 1, negative 1. So that means around my asymptote, it's going to be either up or down or down. And we'll take a look at that in a second. My end behavior, I have low over high. So look at the E, there's a little poem there. It says low over high, 0 equals y. Well, we don't say 0 equals y, we say y equals 0, right? So that means my end behavior is y equals 0. And the last thing, my y-intercept, plug in 0 for x, I get negative 2 over 1. So that means my y-intercept is negative 2. No roots. X equals negative 1. Once you get ready, the graph should come quickly, hopefully. End behavior is y equals 0. And my y-intercept is negative 2. Now I know togetherness is kind of weird and we're not familiar with that, but look at my right side. Just look at my right side of my asymptote. I know I have a dot and I got an arrow, so we connect. We connect. On this side, I could go up or down, but I remember it's together. So if this one's down, then this one also has to be down. All right? Our domain, negative infinity to negative 1, union negative 1 to infinity, and our range is going to be negative infinity to 0, because we go to 0, but we don't go past 0. And last one, number 4, we set the top equal to 0 for RATEY. That means my root is at 0, 0, because if x squared equals 0, that means x got to be 0. Asymptotes, I got 2 of them. So x equals negative 4, x equals 3. I have a squared term on top, so that means it's going to be tangent at 0, 0. My end behavior, now if you were to multiply all this out, you get x squared, blah, blah, blah. So I have x squared over x squared. So that means it's going to be y equals 1, and my y-intercept is 0, 0. All right, so I got 0, 0. I got negative 4, 3 for my 2 asymptotes. Y equals 1 my end behavior. All right. Well, I know I can't, this one can't go down because I'll be creating another asymptote or another root. So those both got to go up. I don't have togetherness, so if this one's up, then this one's got to be down. Same thing over here, up, and this one's got to be down. And then last thing, since it's tangent, this is supposed to go, hit my root, and then bounce back down. And sure enough, it did that. All right. Our domain, since we have 2 asymptotes, is kind of long again. So it's negative infinity, negative 4, union negative 4 to 3, union 3 to infinity, and then my range, be careful here, it's negative infinity to 0, and then union 1 to infinity. And I guess we could say a bracket there because it does get to 0. All right, that's it. Good luck. See you next time. Bye-bye.